Alright, so let's discuss the Gram stain. It was a method invented by Hans Christian Gram, and hence it's called Gram stain. It's usually the first step to distinguish a species of bacteria. So there's two types of bacteria: Gram positive, which stains purple, and Gram negative, which stains pink, if you're using the secondary dye of safranin. And the purple stain is caused by the use of crystal violet. So a gram-negative bacteria has a thin peptidoglycan layer and an outer lipopolysaccharide layer. And this lipopolysaccharide layer is notorious for not really letting things through. And hence it's hard for materials to travel through this outer layer. And gram-positive bacteria or just have a thick peptidoglycan layer and lack this outer lipopolysaccharide layer. So let's view a picture. Here's a gram-positive bacteria. There's a plasma membrane and then a periplasmic space, which is the space between the plasma membrane and the peptidoglycan. And here you can see the thick peptidoglycan, which allows for the crystal violet dye to go in and stick and color this bacteria purple. Whereas here in the gram-negative bacteria, the outer membrane, the lipopolysaccharide and protein membrane, is very hard, very selective, and it's hard for these dyes to actually even make it through and go to the thin peptidoglycan layer. And here there's two periplasmic spaces, one separating the plasma membrane on the inside and the peptidoglycan layer, which is thin, and the other separating the peptidoglycan and outer lipopolysaccharide and protein layer. So that is a distinguishment between the gram-positive and gram-negative. So let's move on. Here's the procedure, which we all know, so I'm not really going to read it off, but feel free to pause it and read it to yourself if need be. So here are the results. Here you can see E. coli after a gram stain. And E. coli is a gram-negative bacteria, and hence you can see like a pinkish color. And I'll zoom in later and show you a bigger picture. And Streptococcus aureus here, or Staphylococcus aureus, I think actually. Let me correct that. It's Staphylococcus aureus, which is gram-positive bacteria, and it's really hard to see in this picture, so I'm going to zoom in later. But it's a gram-positive. And based on that, we also had our patient sample, which we determined was gram-negative, and I'll show you more why. So here's E. coli. You can see that it's a pink bacteria. It's rod-shaped. If you look closely, you can see. And this is it was a control, really. We knew this. This was something that has been proven by other scientists, and we could look it up and figure it out, and we could compare our patient sample. So now, moving on to Staphylococcus aureus here. You can see the purple spherical shape, the coccus representing the Staphylococcus, the coccus in that represents the spherical shape, and you can see the purple bacteria, therefore gram-positive. Now, at our patient sample, this is not the best picture. Well, we'll make it work. You can see that it's rod-shaped for sure, and it's not purple. If you go back and look at it, it's not like that. It looks more like this. It's a pink color. So looking back at the patient sample here, we determined that it was a gram-negative bacteria, and it was rod-shaped. So our sample was gram-negative. It had a pinkish color, and there was a lack of a purple stain. It's harder to see the pinkish color, but you can really see that purple stain is absent. So the crystal violet was really decolorized by the ethanol that we added. So that's a conclusion of this little segment on the gram stain. And, yep, watch the rest of the videos.